day, grade 7. This is Teacher Maan, your Math 7 teacher. So we're going to discuss sets. The first topic you're going to learn about is the fundamentals of set. So when we say set, it is a collection of distinct objects or items that have something in common. A set is also a well-defined collection. When we say well-defined, when we say a set is a well-defined, meaning to say an elements can be easily identified because of their similar characteristics. An example of a well-defined set is the collection of rainbow colors. So, when can we say that a collection or a set is a well-defined set? Collection of rainbow colors. When you name a set, you use capital letters. We're going to use letter M. M as the name of a set is equal to what are the collection of rainbow colors, or what does rainbow colors contain? The colors of the rainbows are red, orange, yellow, green, blue, indigo, and violet. These are the colors that are found in the rainbow. Then we have another example. The collection of favorite colors. Is it a well-defined or not well-defined set? So the collection of favorite colors is not well-defined because your favorite colors may not be your classmates' favorite. So when we say not well-defined, when we say a set is not well-defined, meaning to say elements vary depending on the people's preferences. Your favorite color, for example, is blue, and your classmate's favorite color may not be blue. Then another example is the collection of handsome teacher in GHG. So for example, that certain teacher may look handsome to you, but not to your classmates. So that belongs to a not well-defined set. These elements that contain within a set are called members. The red, orange, yellow, green, blue, indigo, and violets are called the members or elements. So, in identifying the elements, we use the symbol like this. We denote the symbol. This symbol denotes an element of a set, while this one pertains to not elements of a set. For example, pink, blank, set M. So meaning to say, what are you going to put? Is it an element or not element? So, can you see that the colors of set M contains only red, orange, yellow, green, blue, indigo, and violet. So there's no color pink in the given set. So you're going to put not element of set M. Do you understand? Next, we have two classifications of set notations. The first one is roster method, and the second one is set builder notation. When we say roster method, it is also called tabular notation, while set builder notation is named as rule method. So when I say roster method, the elements are listed separated by commas and enclosed by braces. The given example a while ago is set M is equal to red, orange, yellow, green, blue, indigo, and violet. So this is an example of a roster method. How are we going to write this in a set builder notation? Set M is equal to, open and close parenthesis, X such that X is the rainbow colors. So this one, can you see now the difference between roster method and set builder notation? Set builder notation use a rule or a method, while roster method you list each element of a set, then separate them by commas. Another example is the set containing first 5 counting numbers. So this one, the set containing first 5 counting numbers. So how are we going to write this? The set containing first 5 counting numbers using roster method. In naming a set, you can use any letters as long as it is written in a capital letter. For example, is letter V. Set of V is equal to, what are the counting numbers? 5 counting numbers. 1, 2, 3, 4, and 5. This is written using roster method. How are we going to write this using set builder notation? V is equal to X such that X is the first 5 counting numbers. So this is an example of set builder notation. Next, another example is the set containing even numbers between 1 and 20. Set containing even numbers between 1 and 20. No, the set containing even numbers between 1 to 10. So what are the even numbers between 1 to 10? How are we going to write that? Using roster method. So set V is equal to even numbers using rostered method. 2, 4, 6, and 8. These are even numbers between 1 to 10. Then how are we going to write that using set builder notation? V is equal to X such that X is an even numbers between 1 to 10. So this is an example of roster method. So you have the cardinality of set. When we say cardinality of set, this refers to the total number of elements a set contains. If A is the set, then its cardinality denoted by cardinality of set A. The given example a while ago is set of M is equal to a set of the collection of rainbow colors. Red, orange, yellow, green, blue, indigo, and violet. So, how are we going to write this in identifying the cardinality of sets? We're going to write N as the cardinality, then open and close parenthesis, the name of a set is letter M. So, cardinality of set M is equal to, when we say cardinality, it pertains to the total number of elements a set contains. So, how many elements does set M contains? 1, the orange. 1, 2, 3, 4, 5, 6, 7. So, meaning to say, cardinality of set M contains 7 elements. Or set M contains 7 cardinality. So, we have 3 different kinds of set. The first kind of set is a finite set. When we say finite set with countable number of elements. Example, set of odd numbers between 1 to 10. So what are the odd numbers between 1 to 10? The odd numbers between 1 to 10 are odd numbers between 1 to 10 are 3, 5, 7, 9. So these are the odd numbers between 1 to 10. So how are we going to, when can we say that this is an example of finite set? Because you can easily count the members of a set. how many members or cardinality does set A contain? It has 4 elements. So this belongs to a finite set. So what is the difference of finite set to infinite set? When we say infinite set, sets with no defined cardinality, usually described using an ellipsis and with no defined last element. So for example, is the set of even numbers. So what are the even numbers? Set of even numbers, B, is equal to, what are the even numbers? 2, 4, 6, 8, 10, ellipsis. So meaning to say, we have lots of even numbers. So we can write them here, all of them. So that belongs to an infinite set because there is no last element, walang hangganan. There are so many even numbers. Then, another example is set of even numbers between 2 to 4. So set of even numbers, between 2 to 4. 2 to 4. So set of even numbers between 2 to 4 belongs to the third kinds of set. This third kind of set is called a null set. When you say null set, a set with no element denoted by the symbol theta. So when we say null element, you use the symbol theta or as empty. Empty or just the open and close braces. This is also called null set or an empty set, meaning to say there is no element within a set. So what are the even numbers? Even numbers are 2, 4, 6, 8, 10, 12. So we're finding for the set of even numbers between 2 to 4. So is there any even numbers between 2 to 4? So of course not. There's no even numbers between 2 to 4 because even numbers next to 2 is 4. So you're going to write C is equal to open and close braces. Because there is no even numbers between 2 to 4. Another example of a null set. A zebra with 4 ears. So that belongs to a null set because there is no animals or zebra, for example, specifically with 4 ears. Then, man with 40 teeth. That is also a null set because human contains only 32 teeth. Another example, set of counting numbers from 1 to or between. Set of counting numbers between 1 to 100. So are we going to list them down from 1 to 100? So if you're going to list 1 to 100 on your paper or from the board, you will consume much time. So you can write set of counting numbers from 1 to 10. So you can write set D is equal to 1, 2, 3, 4. No, since it is between, we're going to start from 2. 2, 3, 4, 5, 6, ellipsis, 9. 9. So this is how are we going to represent this given set using roster method. So this kind of set, a finite set or an infinite set. So this kind of set is an example of is still a finite set because there is a defined last element. If a set ends in an ellipsis only and there is no defined last element, that is called infinite set. But since this kind of set has a last element found in here, so this belongs to a finite set. Remember that in illustrating or writing a given set in a finite set, there is an exact cardinality of a given set. Then in a finite set, it always ends with an ellipsis and there is no last element. While a null set has no element, usually written just an empty set. So we're going to give more exercises for this topic about the fundamentals of set.